So today we reverse engineering a function of O2Jam. The function in question is a function that marks the nodes as missed if you didn't press them. And I don't have a source code, obviously, it's in assembly. I'm gonna be using X32 debug to view the code. I'm gonna use Visual Studio to write C++ code, and that I'm gonna get from translating assembly manually, and yeah, that's about it. My X32 debug decided to shit itself for some unbeknownst to me reason. Let's give it a kick. That's much better. The function in question is this one, 481C30. It's pretty simple. I think it's a while loop, and it does a bunch of shit with nodes. Specifically, it compares if current measure exceeded the measure position of the node by 19 points, and the point here is 1/192nd of a measure, so that all the timings in O2Jam are measure based, so they are dependent from BPM. And I'm just gonna jump straight in it and tell what's going on while I'm on it, because I never really read through it very carefully. I roughly know what it does and like its general principle of work, but I don't know the details, so we're gonna find that out. I previously reverse engineered the function for timings, and some knowledge will definitely carry over because those two functions are pretty similar. I've already built some scaffolding. So the idea is I'm gonna write this function, h mark miss nodes, and when it's done I'll be able to activate that hook, and when I do that it will effectively replace this function with my function, and it will do all of the work instead. So yeah, it's simple as that. And for detours in particular, and for hooking, MS Detours libraries used Microsoft Detours. So yeah, let's go. This is useless because it just allocates stack for pushing those two things. Those two things return values, not return values, but for unwinding the stack on exit from the function. So basically this belongs to previous function. It does that so it doesn't corrupt the stack for it when it exits. This is the first interesting thing it's gonna do. As we can see, it did move EDI ECX, so that means it copied the value from ECX to EDI, and when you compile C++ code, every time there is a member function of some class, so it's this call type of function, it's gonna be passed at this pointer as its first argument, and it's gonna go on ECX all the time. It's standard. So yeah, what it does here, it copies this pointer to EDI. Now we can see that it copies something to EAX, and it's some sort of member from this pointer. So the offset is 788. I might already have it. No, I don't. So we're gonna mark it down instantly and say that some fucking offset pointer this plus 0x788, and it test EAX performs an AND operation. So when you compare a register against itself, it's basically same as doing like if EAX doesn't equal null, as what it's gonna do. JB is a conditional jump. jump below equals, so less or equal, because it's assembly. I suspect that compiler kinda inverts the jumps, so you get the actual code inside of a loop right after the jump, and the jump leads to the end of the function, as we can see. So it's gonna be if we need to dereference some offset. Actually, no, we don't. We just need a pointer. How did they do this exactly? Yeah, wrap it to desired type and just dereference it. Actually, I don't need those. It's gonna be the word pointer, or maybe even pointer, because I suspect that's probably some sort of pointer, and we dereference it. So now we have some pointer, and if below equals, I'm not sure, it might be not a pointer actually, but a value, because if it was a pointer it would just compare it against 0 and say like if it equals or not equals to 0 it would do something, but here we see below equal, so the value can be less than 0, which is now the case with pointers obviously. So EAX is 7. Well, because it's O2Jam, it's probably, yeah, it's safe to assume that this must be a number of columns. O2Jam at some versions, at least in the future, had different key modes like 3 key, so it makes sense that it has it in some variable. So, or I'm not sure, maybe it's the number of columns that has nodes, like active columns maybe, I don't know. It's hard to tell exactly, but it's not gonna be the word pointer, it's actually an integer. And it's not some offset, but active columns offset. So, active columns. And we're gonna say that it's int pointer. And we'll dereference the value. So now we have if active columns more than 0 is what it does in a loop. Because since the jump is below equals, that means that for that to be executed it have to be above 0, right? So yeah, if active columns is above 0, we're gonna go into that loop. Let's actually see what it does. EAX and ECX are some sort of pointers. 47C, 42C, do I know them? 47C is the closest node. I think it's like the closest node in vicinity to current measure. And another one is 42C. I don't know what that is, but I guess we can find out. So EAX is 47C. I already know that it's, oh, it's a pointer, by the way. So it's some sort of node. I already know the structure of this. This is a pointer to the next node. This is a pointer to previous node. This is a type of the node. This is its millisecond offset, its measure offset. This is a judgment, or like status, basically. 80 means it's, I think, a bad judgment. I don't know what that is. And the rest is bullshit. I've never seen it used. So, ECX42C. Let's see what that is. Again, it's some sort of object, but this one is different. Because we can see that its structure doesn't really look like a node. I think I know what that is. It must be a measure. The question is which measure. So it's an ECX. Do you ever use it? ESP plus 10. Not really. I only use it. It only uses it in the end, so it's hard to tell what it is exactly. I suspect it's measure from how it looks. Let's see if it ever gets a different pointer. D44, 7, D50. No, it seems to be always the same. Let's restart the song. D414, OBO. Yeah, it's always the same. Let's see what those pointers are. Is that a node or some other sort of structure? No, that is definitely a node. And this is... Okay, and this node has a much later position, and it kinda matches the end of the song, because, you know, I recognize the values. So it's a millisecond value, so if we look what it is in decimal, it's 0245F0. It's 148,000. If we divide 148,000, those are milliseconds. So if we want seconds, we're gonna divide by 1,000. We get 148 seconds. 148 seconds divided by 60, 2 minutes and 28 seconds. If we check how long the song lasts, it's gonna be around that long. It's 2 minutes 32 seconds. So yeah, I can tell that this is the first note and last note probably. I'm not sure. It's probably independent from the column, if I were to guess. Oh, okay. Okay, I know what that is. Although it's a bit weird because in the code for judgment it also uses that object, but it's called note end, and the way it got that object was completely different from just using a fucking offset. It used that convoluted fucking way to calculate it. I don't get it. Don't ask me what that means. And it's kind of relevant to the question right now. So yeah, I can instantly mark those down. And we're gonna say, well, we already have processed node. So we're gonna say it's basically it's like an end for a linked list. If the object pointer equals to the pointer of like this end object, that means this is the end of the list, and it points to the first element of the list and to the last element of the list. And we're gonna say it's node end. Uh, 42C. Load effective address. Lea is load effective address. So what it's going to do is get the address this pointer stores. Or more like get the address of this pointer, or like data behind the argument. EAX, ECX. Yeah, it's gonna store it on stack, so we can create a variable and say that song event. I already described the structure of song event. It's like that. It's the same shit I already I was talking about. So it's a pointer to next event, previous event, type, subtype, offset in milliseconds, offset in measures, something I don't know, and it's never used, and the judgment or status. So we're gonna say close this node. It will go in EAX, which will go in ESP plus 14. We'll want to remember what that means because it's going to be used in the future. So closest node is song event pointer and process node. Oh yeah, and we wanted to reference it, obviously. So node and same stuff. Actually, I'm gonna double check if it's really the same, because it might not be. So yeah, this address stores a pointer to the object. Okay, and this guy, yeah, they're the same. This should be correct. Now ESP 14 and ESP plus 10. Let's leave a comment so it's easier to figure out what's going on. They will go to EDX and EAX, and this means we're gonna dereference a value that this address points to. So because we know that the first object on this object, the first value, is a pointer to the next object, this means next node, basically. So ESP plus 14 is our node. So I would create another variable and say it's next node. Actually, no, not like that, but close this node and next event. And for EBP, we do exactly the same thing. I'm not sure why would it need that, to be honest, but okay, I guess that's fine. In theory, that will be a very first event of the chart. because EAX is event end, it would be a first one. But I think this is a while loop, right? Yeah, and as we can see in the end it does exactly the same thing. And returns if EBX. Okay, I think I know what it does. It adds the offset for the pointer to change the column probably. Because if we look how it structured on memory, uh, 10, 16. Yeah, we can see that it's pointer, 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 pointer to various objects, and there are 1, 2, 3, 4, 5, 6, 7, more than 7 of them. It's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So yeah, it's 2 times 7. I guess it's kind of obvious what that means. So (42C) is EE28. Ah, okay. No, it's not obvious what that means. My guess was that they go one after another, but the guess is incorrect. Well, I'm not sure, and it doesn't matter. At least, it doesn't matter now. Next note, event end. Next. I'm not sure what that means exactly. It is a little bit weird. Well, it's first note, quite literally. And it's note end, next event. And now we can see that it compares those two registers. So it compares next node against the first node. And if they are equal, it will not work. It will not be satisfied, so next node doesn't equal first node. Now we get to the juicy part and actual logic of it. Oh, also, it is a while loop, it's not an if. I suppose. Yes, probably, but I'll figure it out later. I'll keep it as an if loop for now, because I'm not sure, there are more conditions that I would have to figure out. Or honestly, yeah, I should probably do that first. Well, this will go to the end of the loop. So what it does, EX and ECX. So yeah, this is the first node for sure. I'm not sure this is actually the node event end object. It might be something else, but it looks like it, right? So oh no, those are pointers to them, and it actually just dereferences the pointer to get the object. So it actually goes like this. And we don't need to dereference them. So this is close this node, and this is node N. This is what it does. Okay. That makes more sense now. So it's gonna be cycling through nodes unless it already reached the end, then it will stop. Since that a while loop, it's kind of important because it could, in theory, start going through the nodes in a second loud. Since that is an endless linked list, it's bidirectional. So yeah, I want to describe the end of the loop to take that out of the way. Let's put a breakpoint and see how it goes. Yeah, ESP plus 10 is exactly the same stuff. I don't think it ever got modified through the execution. Yeah, it's only written once at the beginning, and that is it. So we can be sure that it remained the same. EDX, ECX, EDI. EDI is our this pointer. So 788, we already know what that is, and it is, yeah, the number of active columns. And we increase EBX. Now, what is EBX? Currently EBX is 0. Oh yeah, and we compare EBX against EAX. So it starts as 1. So I suppose outside of that loop, we're gonna declare a pointer that will be, I mean, not a pointer, variable, and name it current index. And it starts with 1. No, it actually starts with 0. And in condition it will be while closest node doesn't equal node end, and while EBX is less than EAX. So end current IDX less than active columns, and in the end of the loop it's gonna be current IDX plus plus. Now those are interesting also, because it adds an offset to our pointers and puts them back in a variable on stack. So it will be current IDX plus plus. I'll leave it in the end and say that closest node pointer equals closest node pointer. I'm gonna say it's a div word. Say plus. We start with x10. x10 is node end, so ESP14 is in closest node. It's ECX. ECX has an offset of 4, so it will be plus 4. You have to cast it to some event pointer. Is that correct? I don't think it is, because yeah, those are pointers to pointers. Okay, so far so good. Yeah, that should be correct. And now node end pointer, we're gonna do the same, but the offset is gonna be different. Also, we should write them in hexadecimal. It's gonna be the offset of C for node end. Okay, and those should probably go inside of the loop then, otherwise it doesn't really make sense. Okay. Yeah, that looks good to me. Now the question is, yeah, we can see that it dereferences those pointers in the beginning of the loop all the time. And then does the comparison. Well, honestly, this is a bit annoying. Because it's executed once outside of the loop, and then it keeps getting executed inside of the loop. This is a little bit annoying. I need to think how to structure that correctly. I mean, I could, in theory, dereference them in the loop, then I don't need those two variables and it's gonna work. I think that's what I'm gonna do. Right? Probably right. Oh, yeah. Like that. And then inside of the loop, I can actually declare those variables that I've just removed. It's kind of dangerous though, because in theory those variables may end up being a zero, and we're getting fucked here because we dereference zero variable, I mean zero pointer. But I don't think that's gonna happen, because as we can see, it doesn't check in original code either. It instantly starts dereferencing them without giving a single care. I can assume it's done somewhere before, I can hope, but it's a potential crash in theory. So yeah. Oh. So it goes like this, and in the middle here we have our actual logic, which starts right here. Yes, exactly. That's the general structure of this function, of this loop. Okay. So first thing it does is dereference something from current node plus 10. If I remember correctly, that is our measure timing probably. Yeah, it is what it is. C0. This value represents node position in a measure. It's measure offset. So we can declare a variable. It's gonna be unsigned integer, and it will be node offset, or for clarity, node measure offset, because there is also milliseconds offset, and we want to differentiate the two. and node measure offset is gonna be not closest node though, it's more like current node. Measure offset, and this should be our argument we get from calling the function current measure offset, because it makes sense, and also it is on stack, and well, arguments are passed on stack, and as we can see, ESP+1C leads us to 19F CC4. Now we look in the stack and we see that it is indeed the first 4 bytes after the return address. So it is the argument. And since I already know that this argument is the current measure offset, we're gonna use it. Now it adds 19 to the node measure offset. And compares it against our measure. I want to already make all of that in the condition for our if loop. So if node measure offset plus 0x19 what JAE, A is above, E is equals, so jump above equals. So if it's more or equals, it's not gonna execute. So this is less. In our case, we compare node offset plus hexadecimal 19 against current measure, and if it's less, we're gonna execute the code. Because if it's less, that means that the node is already 19 points behind the measure, and 19 is the extreme offset you can get, which results in a bad. I mean 18 results in a bad, 19 is already a miss. So if the node passed that threshold, you're gonna get a miss. That's the logic behind it. ASI plus 16 is a judgment, and test AL F0 compares it with, it's a logical end. I'm not sure exactly how logical, I mean not logical, but bitwise end works. So I'm not going to try to explain it because I don't exactly understand myself, but I know that in this particular case, if we make a test against F0 hexadecimal, it will be basically the same as saying that if AL equals 0, in that particular context, not 0, but less than 10 hexadecimal, more like that, yes. So it can be from 0 to F. In our case, anything that isn't 0 or 10 is not even possible, so we can just say that if current node status equals 0, aka if current node haven't been judged yet, if we don't have any kind of judgment on it, or AL puts this value to the lowest byte of EAX, and we're gonna put our AX to ESI 16, which is the status. So current node status equals 80. And I already know what this offset is. It's well, I don't. It's a pointer to the function, which is an event handler, and it does many things depending on the arguments you pass to it, because the first argument is kind of like an opcode, and among others it also executes a judgment basically. So it will play the animations, it will change the statistics and do those things. So we get the pointer to it and we see if it's not 0. If it's not 0, we're gonna pass arguments to it and call it. If it's 0, we're not gonna do that, we're gonna skip it. So I already have a code for that, but basically it's yeah, it goes like this, except not event 9, but it will be 1, because 1 is a judgment event, and 9 I think it's just well, a key press effect, when you press a button without judging any node. And I also need that, please. Thank you. So yeah, we reference a pointer to gameplay event, and we call it if we can. Now let's figure out the arguments we're gonna send. We already know that. Of course it's not 0. Now I'm not sure what that pointer is. I never figured it out because I never needed to, but I just said that it's event handler argument 5 for simplicity in that case. And I have a pointer of 780, I mean offset of 780 already described there. So we already got that. Next argument is, ESI plus 8. ESI plus 8 I think is a node type. I'm pretty sure about that. Now both type and subtype are passed as a single D word in case of that function. So we do this little hack. We take the address of the type, typecast it to a D word pointer and dereference it. That way we're getting a D word worth of data out of this pointer, which is originally a short, so it's only 2 bytes long. Or actually, no, that should be correct. Yes, push ECX. Now this jump is a little detour I said before in the other thing. It's used for fast slow, so it just checks what current judgment is. We don't care about that, but behind the jump, basically original code is everything under the call here. So push EDX, push EBX, and push 0x80. EDX is our argument 5, mysterious argument 5. EBX, what is EBX? Nope. Oh, actually, I don't know what EBX is. It's probably set in my hook, or what to guess, so let's just see what value it's gonna have. It has a value of 1. Well, I think it's an index, isn't it? Oh yeah, it increases EBX. It's our index, yes. So in this case, it's gonna be current IDX. Simple as that. Now we send it a judgment of 80, so 0x80, and the node type, yes. So same kind of hack will apply, but it will be current node instead. Current node type, and we call it. Let's skip that for now. Now we're gonna get the node type and see if it will equal to this value, and what it represents is a long node head type. So if it's a subtype, and if it's 0, it means it's just a regular node and there is nothing after it. If it's 2 or 200 hexadecimal in this case, it's gonna mean that this is a long node head. And if it's 3000, I mean 300 in hexadecimal, it will mean that this is a long node tail. Again, this particular end, as far as I understand, it will basically limit the value to 300 hexadecimal, and it will cut out all the higher bytes, and then it will compare with that value. So I don't need to perform the AND because this is not assembly in my case, and I literally have just a type in a variable. So it will be current node subtype equals 200 hexadecimal. We're gonna execute this code. So if the node that we have just marked as missed was a long node, we should also take the next node, right? And also mark it as mixed, because the next node will be a long node tail. So yeah, what it does, it dereferences the first pointer on our node object, and the first pointer is the next event. So it will get a pointer to the next event. So next node is gonna be equal current node next event. Now again, tests are very difficult to understand. All I can say is that this is a bitwise AND from previously testing what this particular test would do. It is only gonna be triggered if the value of this D word is either this or 300, what is it, 1, 2, 3, 4, 5, 6, so 1 million hexadecimal. If it will be 1 million or 3 million hexadecimal, it will trigger. In any other case that is relevant to this context, it's not gonna. So if next node subtype equals 300 hexadecimal, we're gonna execute some code. So basically that means if next node is long node tail, and this means if node is long node head, So it's gonna set the value of status for the next node to 180. So next node status equals 0x180. And again we're gonna attempt to call our event handler and pass it some variables. So we can copy the code from here and place it. And it does exactly the same stuff with the exception that the judgment it's gonna pass is 180 instead of 80. So 180. It has no reason to be any different. And instead of current node, we're gonna have next node. Oh, actually, maybe not. What node do you use? You use EAX. And yeah, exactly. That's correct. It's next node. Okay. So yeah, next node type. That's correct. Bam, bam. In this particular case, it wasn't a long node, it was a regular node, so the debugging is gonna skip that code. If it was a long node, it would work. And after that loop, right here, actually not even there, but probably here. Let's see. It jumps from okay, it jumps to this point from the check where it saw if the node was already judged, and from comparison if it was a long node, and various stuff about that. That means that this piece of code is gonna be located where did we see the judgment? Did I forget to include that if? Oh no, if, yeah, current node status equals 0. It's gonna go after this if case. So right there. You could say that this is an else case for this if statement. Now, if any of those checks gonna fail, we're gonna drop down to the code right here, because none of those, none of that would happen. So yeah. If any of those ifs gonna fail, we're gonna drop down to here automatically. And what it does, it says that current node equals next node, and compares against the end event, and loops. And loops to right here. Okay, so that means that this if statement is not actually an if statement, but a while. And not only do we have this, but we also gonna check if this is a node end. So this code goes like current node equals current node next event. And that's pretty much it. That's all the code that will go here. Now we compare ESI against EBP, and EBP, as we can see, never changes in the middle of execution, and it's our ESI EBP. Yeah, it's an end event. So we can add a condition to our while loop, and it will be current node doesn't equal node end. Goes like that. Yep. And is there any condition where we're gonna exit the loop? Yeah, look at that. Oh well, this is the first one, which checks the timing. So this is the second statement of our while loop, and we obviously gonna break out of it if it doesn't go. And this, okay, it defaults to this one. We've handled that. This also defaults. We've handled all that. Yeah, it's all good. Now, (81D0C). 81D0C. Yeah, this is our break out of the loop, and we have already described it, I think. Yeah, it's our while loop, and at the end of this while loop we have this stuff. Oh wait, no, that's a different loop. Let's see again. Maybe I've made a mistake. CF9, this is where it goes. CF9 is right here. Okay. Let's see. While node end and active columns. I could make an if statement here at the end and break out of it, break out of the loop if we hit the node end. So instead of having this right here, I would have an if statement. If current node equals node end, we would break. Is that correct? Not equals? Yeah, if it's gonna equal, we will break, yes. How do we hit this code? Okay. I think what I'm doing is slightly incorrect. The loop structure is wrong. This is the first loop. This is the second loop. The first loop is, we already described it. This is the second loop. Now, in case this if is not gonna be, the conditions are not gonna be satisfied, it's gonna execute this little piece of code. And I'm a little bit confused. How would I structure that? If this doesn't work, we break out to there. Maybe this is where this code goes, to be honest. No, I don't think so. That makes no sense. It happens if we go into the first loop, but don't go into the second loop. Can I make while else? Is it possible? I've never written while else, but is it something that you can do in C++? Well, yeah, you can. I guess that's what it is then. So it's while measure offset else. Oh well, looking at how it dropped me down, no, I can't do that. It doesn't let me. While else is bullshit, just as I thought. Too fucking bad. Wait, why am I while loop with else statement? Ah. Yeah, okay. Well, this is bullshit. Okay, let's keep thinking. There must be a way. There is always a way. Maybe it's not a while at all. Can I represent that as if? I think I can actually. There is not a single problem in making this an if. I don't see that it would break anything, right? What is this? Oh, it fixed itself, good. So let's see. Well, you know I'm fucking stupid. It have to be an if loop. A while loop wouldn't even work because I wouldn't be able to update the offset. Oh, this is wrong, by the way. It's not node measure offset, it's current fucking... One of them is wrong. Current measure offset. Node measure offset. Less than current measure offset. Yeah. Now it's correct. Okay. Okay, now it's good. I like what I see, I think. And now we can make an else case, and the code will go here. Simple. Well, yeah, I forgot that in the end of while loop in disassembly form, you will have the condition repeat at the end of it. So as we can see, the condition does repeat. ESI, EBP, it's same shit. So this actually belongs to our while loop, not the previous one, which I thought was while, but it's actually an if. Now it all makes sense. And now we can make an else case. And this is where we'll end up. So let's see what it does. ECX ESP plus 10. ESP plus 10, we already know what that is. It's a note end pointer. Okay, we're gonna get the first node. We're gonna get the first node to EDX and compare the current node with the first node, I think. That's what it does. I'm not sure why. I guess it's something important. Well, let's just code it and see what it does when it's done. So we get first node, and we see that it's okay. It's the node end. Okay. I'm gonna say end event because there is already node end. We're gonna dereference node end pointer. And then we compare ESI against whatever node event will be pointed at by end event, and this is the first node. So, to be fair, it would be clearer if I said song event first node node end pointer next event. Yep. Can I do it like this? No, I can't. Okay. Fine with me. So we get first node event and compare ESI, which is current node. If current node doesn't equal first node, because we see it's j equals. So if it's not equal, we're gonna execute this line. And this line says ESI plus 4. I think ESI plus 4 is gonna be end event, wouldn't it? Because ESI plus 4 is previous event offset, and considering this checks if current node is the first node, this means well, it basically means current node equals current node previous event. That's what it means. And now outside of this if, we're gonna be doing EX equals ESP plus 14. This is the node to process, isn't it? ESP plus 14, yeah, it's process node. Closest node pointer. Okay. So it gets, okay. Wait, what did I do? I think I broke something. No, nothing is broken. So I think what it does is says that the value behind closest node pointer equals current node. So the logic behind this, as far as I can understand it, is if it's the first node, if current node is the first node, we're not going to change it. And we're gonna put the same node we already put through those cycles into the closest node pointer again. So the next time it's called, it will again start processing the first node because the first node wasn't judged yet. And in case it did change and we already passed the first node in a column, we will get the next node. Oh, but look, it goes previous event. If it's not the first node, maybe I fucked something up because it doesn't really make sense, I think. ECX ESP plus 10. It's a pointer to the end. We dereference it, so we get node end event. And then we compare ESI against the first node. Yeah, if it's not equals to first node, we'll put previous event to ESI again. No, I think I didn't fuck up. It is what it is. Okay, I think this else case is done. It's our while loop. Well, yeah, that's it then. If I didn't fuck up anywhere, this is literally it. It's done. Let's check. The first if jumps to, yeah, the end. Good. What about this? While. Okay. I think it should work. I'm just worried about this little piece. I'm not sure about this. Not sure if it will cycle correctly. Well, let's see. Now, if everything is correct, we should get misses appropriately. And considering the autoplay is implemented as converting misses into perfect judgments, the autoplay should be working correctly now. And work it does, as far as I can tell. Yeah, it missed the long note properly. I mean, that's about it. It judges the regular notes, marks them as missed, it cycles through them correctly, and marks long notes as missed. If you miss the head, it instantly marks the tail, so yeah, I think that's about it. It's done. It's simple enough that it's possible to not make any mistakes, and that wraps it up. This is how reverse engineering some function looks like, translating it from disassembly into assembler view. Now I'm slightly curious what the compiled result looks like relative to original code. So I'm going to compile a release version of executable because debug is really not the best thing to look at. It has a lot of unnecessary stuff. And let's see what it looks like in disassembly. How much different is it when it's compiled with a recent version of Visual Studio compiler versus like 2005 version of it? Because as far as I know, O2Jam is compiled by VC compiler also, but obviously a much older version. So here's our miss function. Oh wait, Did it not set the hook actually? It should have. Why don't I see it on disassembly then? Am I missing something? Yep, the version of the file is recent. It's 143 kilobytes, so H mark missed notes. Overrides P mark missed notes 81C30. C30 should jump to mark missed notes function. It's my function. This is correct. C30. Why don't they see my code here? Man, this is confusing as fuck. Because it should look like that. We should see at the beginning of a function a jump to my code. So jump to O2 hook module. But I don't see that here. Why? 81C30. And if it failed to hook, we would have an error box, but we don't see that. Am I stupid? Yeah, and analyzing it doesn't help. Huh. Well, this is weird. I'm gonna compile a debug version so we get debug symbols. I'm gonna try and see if I can find my function and see if it's code. Replace. I could still get nothing. Oh, this is so confusing. So, to find my function, I will go to symbols, go to O2 hook, and there should be a symbol pointing to my function, and my function name is H something something, right? Ah, mark missed notes, there it is. So this is my function in theory. Is it being called somehow anyway? Well, no it doesn't. Of course it doesn't. Why would it? I would see it if it did. That is extremely fucking confusing. What am I missing? Genuinely, I have no idea whatsoever how is that possible. Well, I mean, I can debug it, that's for sure. Something I can do. But I probably want a bit of delay then. Oh, that's why. I removed the hook. Oh, that makes sense. That explains it. That explains it. Should have checked first thing. Yeah, okay. So, does it work? No, it doesn't. It's broken. It missed the first line, I think, and that was that. We get 8 misses because long note counts as 2 notes. So I can tell for sure that my suspicion this little else case is wrong was correct. It is wrong. If I were to guess, it shouldn't be doesn't equal first note, but rather equals. Because that makes no sense otherwise. Oh yeah, I already killed it. So I'm gonna comment this out for now. And let's see what this piece of code in original function does in debug. So it's that stuff right here. Actually, maybe it does work. Because if it didn't, I think it would cycle through all of the notes instantly. It would cycle to the next note each frame, which it doesn't do, so that should be correct. So, ESP plus 10 is our pointer to pointer. Okay. Then we dereference the shit to EDX, so we get the actual event pointer on EDX, and as we can see, this is indeed a song end event. We can tell by looking at it that it's well, it's bullshit. All the data we can see that doesn't make any sense for a normal song event. The only thing that is correct are the first 2 pointers. And then it compares ESI, which is a current node. Yeah, it's the first node because, well, it's the first time this function is called, so it's gonna get the first node of them all, right? It compares it against the value at the address which EDX points to. So it's A3720. A3720 is the first node indeed. And yes, it compares the current node to the first node. And if the current node is the first node, so it's our this stuff. Now it should get the previous node, EX ESP plus 14. This is a pointer to the first node, I believe. Now it does, it writes ESI to what EX points to. So this pointer is gonna be replaced to our ESI. And yeah, it just didn't change because it's the same value right now. But this is what it does. The error, however, is somewhere else. We don't cycle through the nodes. We only judge the first line and it stops there. So something breaks. I guess I should debug my code and see really. Yes, we detached. I even... Oh yeah, I should install the hook again. Let's attach. Now we hit the breakpoint. Active column 7. I think it's the first cycle. So it shouldn't be very interesting for me now. Get the pointers. Okay. Get current node, end node, end. Yes, we can confirm node end is correct, and current node is also correct. Measure node, measure offset is C0. Now I probably want to set a breakpoint here and see what is gonna happen if it's not the first node but something else. If it ever gonna change to that. Because currently we can see it's still C0. We're interested in this. I think it cycles through columns now. Yeah, and we can see it seems to be stuck at the first column now. While what about current offset? 32 FC. Yeah, so we can see that current measure offset moves, but the nodes don't. So there's something wrong with how it cycles, because this should execute and it seems to never execute. Maybe this if is wrong straight out. So okay. Yeah, because if current measure offset is less than measure offset, so if this node already passed, we'll check the status. Oh look, it's because of the status apparently. It's 80, it judged the first line, so that makes sense. Now it sets the node to next event. I think this code should execute outside of else, because if we don't hit the else, we never cycle to the next node. That's why it doesn't work. Because this little piece actually cycles the nodes. So yeah, again, the loop structure is wrong. That's my mistake. Because now we're never gonna hit that code. Like I can even set a breakpoint. It'll never hit it. Yeah, see? We went through all nodes and never hit that breakpoint. Only hits it on the first line. And that's it. Yep. There goes first line. 3, 4, 5, 6, 7. And that's it. That's my mistake. Okay then. It shouldn't even be else. It should always execute in both cases, I think. And this little if will determine if you should cycle to the next node or not. So yeah, I should just take down the else, and that should be it, really. I don't see why that wouldn't work. Let's try it. No. Oddly enough, it still works exactly the same. Not sure. This is confusing. Okay. This is the very end. Yeah, it doesn't default to this code. It is literally an else case for this if condition. At no point do you ever get to this code. Oh, actually... Oh yeah. Okay. It would default to this code. But this stuff is an else case. That seems to be correct. So why don't it cycle? Do I override current node? Yes, I do in the very beginning. I get the current node from closest node pointer. ESI EDX. We get ESP ECX from ESP plus. No, wait, that's my else case. I wonder about this. Well, yes, it says ESI is ESI next. Goes to there. First thing it does here is compare ESI against EBP. Okay. It really does seem to be an else loop, to be honest, because as an if loop it doesn't quite function. But then, what do I do about this little else case? Compare ESI EBP, so it's while ESI EBP. Okay, I think I start to understand something. This is indeed an if, while ESI EBP. This, okay, okay. I think I should take those two out of the loop. Okay. Now, I took them out of the loop. It could be two while loops, to be honest, instead of one with an end. And that would pretty much solve all my issues, I believe. So it goes like well, current index is less than active columns, and while current node. So we would take this in because we need to update current we need to change the columns of node end and current node, so we have to call it inside of the beginning of index loop, and we're gonna say that current node doesn't equal node end. This stuff belongs to the outer loop. Now let's see, does that make sense? Now this goes as an inner loop. And this where it defaults to, right? If this is not gonna work, it might have to go outside of this while loop too. Does that make sense? I think it doesn't. I think I've mistaken again. Oh, while... Oh, okay. No, it did make sense. I'm getting tired a little bit. My brain stops working. Yeah, it will not be an else, but it will stay inside this while loop. This is it. Yeah, now that makes sense to me, I think. Let's see. Oh, Stump Crushers, good song. No, I killed it. It's stuck in an endless loop. Let's see where it's stuck at. Okay. It indefinitely cycles through the nodes. That's not good. Maybe it did have to be else. Oh, it managed to recompile. I don't really trust that shit, to be honest. Unable to detach. Well, just kill it then. That fixed nothing. Oh wait, compare EBX on the outer loop in JB to here. Again, updating the nodes. Oh yeah, that's comparing active columns against current index. Okay, yeah. Fair. And it starts from updating the values for current node and node end. So yes, it does that. And it defaults to this little piece. Yeah, and all it does is the index. So I'm pretty sure my outer loop must be correct. That is all it does. Now, inside of it, we get ECX ESI plus 10. ESI is our current node. AX is current measure. We compare current measure offset of the node plus misjudgment. Oh. This is hardcore syndrome 10, by the way, and 8 ran out, so we go to 11. Now I think the while loop with 2 conditions was, to be honest, correct, kind of. Yeah, you see, this is confusing. Okay, and here we go, comparing it, JAE. We're gonna execute this exclusive to this scenario code. So it's definitely an else, right? And normally we do this. Test if there is judgment. If there is no judgment, we get the next node. Okay, let's see. We check the judgment. If there is some sort of judgment, the thing we do is get the next node, start the loop over. This is exactly what it does. It starts the loop over if node doesn't equal node end. Well, yeah, but this is exactly what happens. It's gonna go to next event, go outside of the if loop, and hit the beginning of the while loop again, which is gonna make this check if current node doesn't equal node end, and it will start it over. It will grab the values for the current node, add the value, do this, and boom. Oh shit, you know what? Now that I think about it, no, it should be good. Nothing should break, really. Autoplay shouldn't break. So why wouldn't it work exactly? I mean, it makes sense to me. I don't see my mistake, really. Just gets the next node. Okay. Yeah, I literally can see it. Okay, current index 0, active cost 7. Well, current index less than 7. What are we doing in that loop? Current index plus plus. Okay. Well, current node doesn't equal node end. Shouldn't I have some way of breaking out of this function then? Maybe this should have a break, really. That's what I'm forgetting. Well, yeah. Because if we hit this function with all of that, yeah, and we never start the loop over, it simply has a break that I forgot. I'm so stupid. So yeah, that shit should have a break. That's it. I somehow missed that, which I usually don't, because I have never had an issue of missing a break, especially when it's kind of obvious. Well, that was, what, half an hour wasted to basically nothing, maybe like 20 minutes, 25. Felt like eternity, to be honest, I'm not gonna lie. Oh shit. Game crashed. Yeah, shut up. Well, at least I like double and triple check my code. It seems to be correct. Yeah, well, that's about it. Now it works. Seems to be working correctly, right? Yep. Yeah, the tour is placed. Currently my code is being executed. Am I not correct? Yep, it is being executed. Okay. No, that is the function, actually. So here are my offsets that I have in the beginning of a function. My code is much simpler. I think I have any optimizations off as far as I remember. So yeah, we can see that it literally just compares to 0. It doesn't really transfer them to like registers to use something like test or anything like that. So my code in disassembly form looks very straightforward, I would say. Very basic. Yeah, I think it works. Let's make sure it misses the long notes correctly. Yes, it does. We instantly got 2 judgments on the first note. Well, yeah, that's about it. Now let's see in release what it's gonna look like. Oh yeah, that's more like it. That's more like it. Now we can instantly see that instead of comparing against a 0, it uses tests and all of that. It looks a lot more like the original code now, I think. I would love to compare them side by side. I need to open another instance of 32 debug to do that, which is kind of funny, to be honest. I can't like open two CPU windows and have them point to different addresses. That's not possible to do. Kind of hilarious. But whatever, it doesn't matter right now. Good enough. Where is my miss window? Good. Yes, that's the thing. Okay. So again, it allocates some stack. What is that little call? That should does something with threads. It's probably not very interesting, but yeah. Now we can see that it gets our offset. My code also does something else. It puts EAX on stack. I think that's my column index variable, EBP plus 10 in that case. Test EAX, GLE, GBE, I think it means literally the same thing, it's just a different instruction. Jump below equals jump less equal. I'm not sure what's the difference, it probably compares different flags maybe? Let's see. So JBE, jump short if below or equal when CF equals 1 or ZF equals 1. And GLE, jump short if less or equal ZF equals 1 or and ESF. I'm not sure what that means, it's something confusing. But yeah, basically just uses flags slightly differently, but more or less same thing. So yeah, as you can see, the compiler actually inverted my if case. Like the condition was doesn't equal 0, right? And now we get jump, which is pretty much the opposite of what I said. Oh no, not doesn't equal, it was more than, right? So yeah. Now we get the address to 47C. It uses Leo also in exactly the same way. Now gets 42C and puts them on stack in variables on offsets 4 and 8. So it's pretty much the same so far. Not sure what that is. I think X64 debug actually misinterpreted some line here, because that doesn't quite make any sense. Or I don't know what that means, like nop and then actually some code. That's confusing. I'll just ignore it. So yeah, now the references those two in registers to get the actual nodes and compares ESI against EAX. In my case, EAX is node end and node end here is EBP. So yeah, jump equal, moves from ESI and adds the offset. Well, offsets are different in my case, but it's whatever. Oh look, in my code compiler compares EAX against an actual variable on stack, which is unusual because I have never really seen it do that in O2Jam compiler. It only compares, it copies the value to some register basically, it never does it that way. EBP plus 8 is an argument passed to my function. And again we see GAE, compare against 0. Well, this is basically same, it just does the logical, bitwise AND instead of literal comparison, but it means literally the same thing, and we get G and E. Then we copy 80 to the thing, exactly the same fucking code, copies it as Word, Movie X tests the fucking object if there is a function, jump equal, passes arguments to it, more or less same thing. Oh look, another thing the old compiler have never done, I have never seen it before, is pushing that way. Never done it before. I didn't even know that was possible, to be honest, because I have never seen it happen. But yeah, because as you can see, it first dereferences, not dereferences, but copies this value to a register ECX and then pushes ECX. Here it instantly pushes the value from the address. Cool! Compares against 200. Again, same thing, but uses dword here, and also, well, yeah, just uses dword there instead of comparing only 2 bytes, whatever, practically same. Jump not equal, movie X ESI. Comparing against 300, again, doesn't matter, practically the same. Oh look, oh no, it's not inverted because tests work differently. Here we have direct comparison, here we have a test. The jumps are inverted relative to each other, that's normal. And we push 180 in the same manner, again call this function. Comparing ESI against EBP, again, O2Jam never compares against values on some offsets, it only compares them directly from registers. Jump not equal. And here we can see that the code of O2Jam jumps to this code. In my case, it, I think, executes it instantly and then jumps. Or maybe, oh yeah, basically my code, instead of jumping to here, it jumps to there and executes this little piece inside of the ending for previous loop, if that makes sense. Yeah, adds offsets exactly the same stuff, increases EBX, it does it before, mine does it after, whatever, and pushes the values, compares EBX against EAX, EBX against this, jump less, jump below, same stuff. So yeah, basically even though I was coding it in a coherent C++, the ending result disassembly is practically the same, which is impressive. I guess that means that in 20 years of developing the VC++ compiler, not that much really changed. We can see it's like more aggressive with pushes and stuff, and doesn't use registers as much anymore, like directly. I guess because it's probably got optimized on recent like hardware, so it's not that necessary or something like that. But yeah, the functions look extremely similar in the end, almost identical, I would say. So I say this is a win. Well, if someone will ever watch that shit, thank you very much, and hope you learned something and it was slightly interesting. Have a good day.